Hello everyone. This video is an introduction to some basic statistics. In particular, I'm going to talk about the mean. Now in everyday language, we usually say average when we're referring to the mean. In statistics, there are different kinds of averages. There are different ways to describe a set of data. And average can be the mean. It can also be the median. And today I'm going to talk about the mean, which you probably remember, is where you add up all the numbers and divide by how many numbers there are. Typically, when we're thinking about average, we might think of our test grades, for example. Add up all your grades and divide by how many there are. And that's your average. Really, that's your mean. But why do we do that? Why do we add up all the numbers and divide by how many numbers there are? And what does that really tell us? And what does it not tell us? So I'm going to try to give an intuitive understanding of the mean. Now, to get a real deep intuitive understanding of something, it's usually helpful to see it visually, concretely. So I'm going to use my game pieces here. So first, I'm going to use these to represent a bunch of numbers. So let's do 4, 8, 6, and 2, 7, and 3. So we have 4, 8, 6, 2, 7, and 3. And we could think of them in context. We could think of them as test scores, quiz scores, something like that. Maybe they were out of 10, maybe they were out of 8, maybe they were out of 5 and extra credit, who knows. We could think of them as maybe ratings on a scale of 1 to 10. So maybe a YouTube video was rated by 6 people on a scale of 1 to 10, and the results were 4, 8, 6, 2, 7, and 3, for example. But the context doesn't really matter. The goal is to represent these numbers with a single number. What one single number could we use to describe the overall performance, or the overall rating? And so one way we can do that is by asking, well, what if we redistributed these numbers so that everything was equal? Before I do that, I want to keep track of the numbers. So I'm going to write them down here. So these are our starting numbers. And so I'm going to take these numbers and redistribute things so that everything's equal. example, we could take some away from the 8, bring it down to the 2, take some away here, maybe 1 here, and 1 here. And now, all 6 of the numbers are 5. So what we've done is we've figured out what number could we have every single time that would give us the same total as the numbers we started with. So in some sense, having a 4 and an 8 and a 6 and a 2 and a 7 and a 3 is, again, in some sense equal to having 5 every time. Now, why is that the average? Why is that the add them all up and divide by the number of numbers? Well, here, if we add them all up, we're just simply taking the total number of pieces, which in this case is 30, and then we divide them equally among 6 parts. And that's why we get 5 in each case. So taking the different values and redistributing them is the same as adding up all the numbers, getting the total, and dividing it by how many numbers there are. So now we can see we have 6 5s. So it's not the same set of numbers, but it tells us kind of a middle. And that's why we use that to represent the set of data with a single number. So if the results of the evaluation or the test scores, whatever, were 4, 8, 6, 2, 7, 3, we can say that these numbers are all sort of centered around 5. But literally what we mean is 5 is the number that we could repeat that many times and have the same total. But when we say the average is 5, we don't know what the numbers were to begin with. They could all be 5s. They could all be a little different. They could actually be quite different. For example, we could have, as in this case, a 0 here, 30, 0, 0, 0, and 0. If we add these up, we get 30, divide by 6, we get 5. So a 0, a 30, and a 0, a 0, a 0, and a 0. I have an average of 5. So getting the same thing every time, average of 5, again, getting slightly different numbers each time. An average 5, getting extremely different numbers every time. We could average 5. Do another one. We could have a 2 here, a 1, a 0, and a 1. So what is that? We have a 2, a 1, a 1, 0, and a 1. And that leaves 25. So again, an average of 5. But very different numbers. So for example, if we had quiz scores out of 30, and one person got 30 out of 30 on one quiz and zeros on all the other quizzes, their average is 5. Another person got a 5 on every quiz. Their average is 5. We'll probably make different conclusions about what those students know. Here we know they did this much on each quiz. Here this student, maybe they know a lot about this particular topic, or maybe they were absent on the other ones. We don't know. So this reminds me actually of a quote, somewhat famous quote about statistics. And I don't remember the author who it's from, but I'm going to paraphrase the quote for you. And you can look it up. It goes something like this. Statistics are like swimsuits. What they reveal is suggestive, but what they conceal is vital. So here telling you that a set of numbers has an average of 5, it does tell you something. It tells you where they're centered. It tells you that with 6 numbers, an average of 5 means the total is 30. So nothing with an average of 5, maybe somewhere above and somewhere below, but they can't all be above 5. Or they can't all be below 5. So you do know quite a bit of information. But what information is concealed, and that is how the numbers are distributed, how much variation there is, in other words. The mean does not tell you whether they're all very close together or whether they're all very far apart. And that's something that we'll talk about in another video. Standard deviation and other measurements that describe the variation of the numbers. So the mean tells you quite a bit, but it does conceal some important things. There is another statistic that I didn't mention yet, and that is the mode. And the mode is simply the number that occurs most often in the list. So having the mean and the mode gives you a bit more information. But here we can see that in this case, this last case, the number 1 appears 3 times, whereas all the other numbers only appear once. So in this case, the mode would be 1. Here we have 5 zeros and a 30. So the mode is 0. So telling someone that there's 6 numbers with an average of 5, but a mode of 0 tells you there were at least a couple of zeros. So you know that there's some variation. There's some zeros, so there must be some very high numbers as well. but again, we don't know how many. If the average, or the mean, is 5, and the mode is 5, as it is here, that tells you that there were at least a couple of 5s, and so we know that there's some consistency, a little bit more consistency than that in this case. But we don't know for sure that they're all 5s. And here you'll notice that each number appears exactly once. There is no number that appears any more than any other number. And so in this case, we'd say there is no mode. So each number occurs only once. And it is possible to have 2 modes. If, for example, we had 2, and this would be a 24. Now we have the number 2 appears twice, and the number 1 appears twice, and no other number appears more than twice. And so in this case, there are 2 modes, 2 and 1. But if you know, for example, that 6 numbers, the mean is 5, and the modes are 2 and 1, well, that does tell you quite a bit. There must be 2 2s and 2 1s, but it doesn't tell you what the other numbers are. It could be very different, like this, 24 and 0, or they could be very close together, 12 and 12. So the more statistics you have, the more information you have, the better conclusions you can make about the data. So the mean is the thing that people are most used to using. But as you can see, in some cases, it's a very good representation of the overall performance. And in some cases, like this one, it could actually be a little bit misleading to say that the mean is 5. It's true. What it reveals is suggestive, but what it conceals is vital.